Hi, everybody. Welcome back to school. It is April 14th, 2020. I hope you enjoyed your spring break. I'm excited that I can be talking to you. We're going to start on chapter 7. So remember, you can always use your textbook. We're going to do 7.1 to start with, and that's on page 401, 402 of your textbook. If you didn't bring your textbook home, no worries. Remember, you have an online textbook, and if you can't find yours anymore on your Chromebooks, please send me an email and I will share it with you again. So the lesson for today is looking right now for a pattern. So take a moment and see if you can see the pattern. These are fractional or rational exponents. We're going to be working with them. They work with roots. And if you look at it, you can see we no longer just have square roots. We have cube roots. We have fourth roots. And then here's the square root. And with a square root, it's understood that the 2 is there, just like it's understood that it's 1 times z. So did you figure out the pattern? Did you notice that the denominator of the rational exponent or fractional exponent is the root number, and that root number is called an index? And did you notice that the numerator of the fractional or rational exponent is the exponential power? Same thing here. Here's the denominator. It's the index. Here's the numerator of 7. It's the power or the exponent. Here's the denominator. That's the square root. Remember, that's understood. And here's the numerator, which is the exponent. And if you notice, we can either put the exponent in parentheses on the outside of the whole expression, or we can put it underneath with whatever is underneath the root. So just a couple things to review. First of all, what we're going to review is that if you square 3, so 3 squared, which is 3 times 3 is 9, that means that the square root of 9 is going to be 3, because you need 2 to take 1 out. And if you have 5 to the third power, so 5 times 5 is 25, and 5 times 25 is 125, so 5 to the third power is 125. That means that the cube root of 125 is 5, because for a cube root now, instead of needing 2 to take out 1, we need 1, 2, 3 to take out 1. And then if we have 2 to the fourth power equal to 16, then we know that the fourth root of 16 is going to be 2, because now if you have the fourth root, you, instead of needing 2 or 3 to take 1 out of the same number, you're going to need 4 to take 1 out. Let me move that over a little bit. Okay? So going back to what we know from the do now at the top, we know that the square root of 25 could be written as 25 to the 1/2, because the root number, the index, is 2, so that's the denominator, and the exponent is understood to be 1. So the cube root of 27 could be written as 27, that's our base. The index, or the root number, is 3, so that's the denominator. and the exponent is 1. Next, we know certain things, and we have to think about these. These are important because we have to think about our negatives, our positives and our negatives. So, negative 3 to the third power. We know that means negative 3 times itself 3 times. We know that a negative times a negative is a positive times a negative is a negative. So we know our answer is going to be negative. And then we just do 3 times 3, which is 9 times 3, which is 27. Negative 3 squared, we know to be negative 3 times negative 3. A negative times a negative is a positive. In fact, our even exponents are always going to give us a positive number. So negative times a negative is a positive. 3 times 3 is 9. And if we look at this one, our last one, we have negative 3 to the fourth. So negative 3 times negative 3 times negative 3 times negative 3. Negative times a negative is a positive, times a negative is a negative, times a negative is a positive. Or you can say this is positive, it's going to be positive. So now it's 3 times 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27, times 3 is 81. What's a little easier when you have 4 is you can multiply these two, and that gives us positive 9, these two. That gives us positive 9, and 9 times 9 is 81. All right, so now we're going to write these in exponential form. So here they are in radical form, and we want to write these in exponential form. So our base is going to be 14. We have an understood exponent of 1. So we have 14. We know that the exponent is the numerator, and we know that the index or the root number is 4. So 14 to the 1/4. For the next one, I've made a mistake. This should be a 7. So now I'm looking at this, and we said earlier really quickly, so I want to go back to it and make sure you understand this, is that whether this exponent is outside parentheses with this type of a problem or under the radical with the base, it's the same thing, and we have to decide which way we're going to use it so it makes sense to us, makes our life easier. So what we're going to have here is we're going to have 5, and this is going to be the numerator and the denominator. We're going to look at this one. It's 2, numerator, denominator. So we're just following a pattern. Now going in the other direction, this is the root or index. So it's the 4th root. This is our 7, and it's to the 1st power. This is 10. This is our root number, and this is the exponent. Remember, it could go here or it could go on the outside. So we have one more thing I'd like to go over with you, and it's evaluating. And again, this is just a reminder that a to the m over n this is my root number, this is my exponent, and it could be under or out. So if we're looking for the cube root of 64, we want to know what times itself 3 times is equal to 64. And we know how to prime factor. And I normally did it this way, if you recall. All right, so it's 1, 2, 3, 4, 5, 6. 6 twos. So I have the cube root of 2 to the 6th. Now let's use the pattern. I have 2. This is the numerator. This is the denominator. 6 over 3 is 2. And 2 squared is 4. So all you're going to have to do, if you don't know these numbers, is to prime factor. This is 1, 2, 3, 4, 5, 6, so that's 2 to the 6th. Remember the pattern, 6 over 3, that's 2, and then 2 squared is equal to 4. Let's look at this one. 16, 2, 8, 2, 4, 2, 2. So I have the 4th root of 2 to the 4th, the whole thing squared. All right, so we know this is, look at this first. Remember, you're going to do inside the parenthesis. So 2 to the 4th root of that. So that's 2, 4 over 4 squared, which is 2 squared, which is actually 4. We've got 2 more to look at. Now these are written in exponential form, so we have to think about these as a root. So if I'm looking at this, I know that this is the square root of 9 cubed, and I could put the 3 here, or I could put it on the outside. But I have a question for you. Do you, one or the other. One or the other. So if I do it under here, do I really want to cube 9 and then take the square root? I don't. So what I'm going to do is I'm going to put the 3 out here, which means I'm going to take the square root of 9, right? Square root, the 2's understood. So that's 3. I have this to the 3rd, and if you remember from earlier work, 3 cubed is 27. One more. I've got that negative exponent. Think about what we do with that. So this is going to be 1 over 32 to the 2 over 5 power. So let's use our pattern. That's our root or index, 5th root of 32. I'm going to put the squared out here again because I don't want to square 32 and take the 5th root. So now, if I prime factor 32, 2 and 16 and 2 and 8 and 2 and 4 and 2 and 2. 1, 2, 3, 4, 5. So I have 1 over the 5th root of 2 to the 5th, not 6. 2 to the 5th. And this whole thing is squared. So the 5th root, so this is 1 over, if you want, 2 to the 5 over 5, the whole thing squared. And that would be equal to 1 over 2 squared, which is 1/4. Or you could know that these undo each other. Therefore, what I'm going to get is just plain old 2 and square it. And 1/4 would be our answer. So please check your note sheet that has these problems on it. The note sheet has more problems than this, but please check your note sheet, and we'll do the rest of those problems tomorrow and talk about solving. And I'm going to give you an assignment to do, and that'll all be on Google Classroom. Hope all of you are well and safe, and miss you a ton, and looking forward to seeing you as soon as possible. Take care.